So what is the statistics? That is what has been said. Statistics is actually the branch of science that deals with data collection, okay, data organization. From data organization, deal with data analysis and data presentation, which is same as data collection, data simplification, and description of data. That is what you're studying in statistics. Statistics is grouped into branches, by the way. There is descriptive statistics and inferential statistics. So with the descriptive statistics, you are dealing with the collection of data, you simplify the data, you try to describe this data, okay? To describe the data, that simply means giving some properties or characteristics of that data. How is that data actually? Then from inferential statistics, this is a process of making judgments about the population based on the properties of some sample obtained from the population. You know that when you are researching, you do not, it's not possible for you to get, to look at the characteristics of the entire population, or you can't use the entire population. It's very difficult. So most of the times what you do, we get the fraction of the population. Now that fraction, we'll choose some fraction of the population to represent the entire population and analyze the characteristics or some variables that we want to study. So now, when we look at the characteristics as shown in the sample, then we are able to draw some conclusions. Okay, that obviously, if the sample has got the following characteristics, obviously even the population has got such what characteristics. Okay, so the process of making judgments about the population, that is actually based on the properties or the characteristics of the sample that you get from the population, is what is called the inferential statistics. Is that okay?
Yes, please.
If that is okay, then what is a population? The population actually, it consists of all the items, the individuals about which you want to draw a conclusion from. A large population, so we can say maybe UNZA population, you want to research about the behavior of students, maybe consumption behavior. The whole UNZA students, like the whole UNZA, the whole UNZA populace, that is your population. But from, you want to ask, you want to question all the UNZA students, you just select maybe 100 or 200 of them to represent the entire population of UNZA. You ask them the questions that you want to ask, then you draw conclusions. That fraction which you draw is called the sample, okay? But the entire UNZA populace is the population. So the sample is actually the portion of the population, a fraction of the population. It's still a very small group. Clear?
Yes, please.
Okay. If that is clear, then we can now talk about parameters. What is really what a parameter really is? So a parameter is basically a numerical property of the population, such as maybe the mean, okay, the mean, the standard deviation, the mode, the frequency, the median, all those things, right? Those things that you use to analyze the entire population, those numerical properties, okay, of the population. Right? So those numerical properties is what we call the parameter. Hello. Okay. So statistics, it is actually a numerical property of the sample. So just know the difference. So the statistics are basically the numerical properties of the sample. Okay, so they describe the property about the sample, maybe the sample mean, the sample standard deviation. As long as you get those characteristics from the sample, we call them the statistics. But if you get them from the population, they are called a parameter. Did you get that? Hello? Okay. I don't know what has happened. I'm unable to hear you, but your mic is even on. Okay. A random sample now. Let's talk about a random sample. All right. So I was just saying that um, there are different types of the random samples. Okay. They're just different types of random samples. So we have got the simple random sample. We have got the stratified random sample. We have a cluster sample and the systematic sample. So these are the different types of samples that we have. So the first one is the simple. So now, short in detail, we are looking at data collection. We are looking at the techniques that we are using when you're collecting data. So in short, when you're collecting data, of course, you want to get just a data of some sample. You are selecting some sample in short. Selecting some sample from the entire population. That's how you collect data. So now these are different ways of selecting sample. The first one that you use when you're selecting sample is called simple random sample. So the simple random sampling, this is where you what happens is that it is actually a random sample that is selected. It is a randomly selected subset of a population. This is a simple random sample. You select it random. So what happens is that each member of the population has an exactly equal chance of being picked under the simple random sample. So the chance of picking this one is equal to the chance of picking the other one. Yeah. So how do you perform the simple random sampling? Number one, you define the population. Now, what is to define the population? So what happens is that you start by deciding on the population that you want to study. That's defining the population. What population do you want to study? Is it the student? Is it the old people? What do you want to study? What is the population before you can select a sample? Then number two, you decide on a sample size. Like how large should be your sample size? Do you want 100 people, 200 people, 30 people, 20 people? Yeah, but most of the times your advice is over 30, above 30. Okay, your sample size most of the times is supposed to be above 30. Is that clear?
Yes, it is.
Yeah. So you decide on the sample. Yeah. So you know that again, the larger samples are usually good as compared to the small samples. Then what you do now when you decide to choose the sample, you've chosen the sample, you randomly select your sample. Okay. For example, just the way how you do, you know, the lottery game, right?
Yes.
That game, yes. So you are selecting the figures randomly. So yeah, there's nothing like no, there is favoritism. They've chosen this and that. So this is where you're just selecting the people or the objects to form the sample randomly. Yeah. Okay, stratified sampling. This is the other one. So this is where you divide the population into subpopulations, which you call the stratas. The subpopulations, you call them the stratas. So most of the times, you use that one. Okay. So you divide the population into subpopulations. Those you would call them the stratas, okay? And you sample from each stratum. One is called the strata. So we are going to start selecting now from each province, okay? If you want equal presentation, we'll say, okay, we are picking people from each province. And again, but first of all, you don't just select maybe all the people from Lusaka. We want equal representation. So what you do when you're using stratified sampling, you have to select from different strata. Divide the population, then select it. If it is in a province, you can divide maybe into districts and select from each district. Did you get that?
Yes.
Yes. So that's what usually happens. So in a cluster sampling, usually researchers divide a population into smaller groups that we call the clusters. You usually call them the clusters. So then they randomly select among these clusters to form a sample. How to cluster sample? The simplest form of a cluster sampling is a single stage cluster sampling. So it involves actually 4 key steps. And the following are the steps. Number 1, you define the population. After defining the population, you divide your sample into clusters. You define the population, get the sample, divide into those small clusters. Then after that, the third stage is that you randomly select clusters to use as your sample. You know, cluster sampling is almost the same as stratified. I want you to get the difference. With the stratified sampling, what you do is that you divide into strata, right? Then you're not choosing the entire stratum. You're following, right? You are doing random sampling now from each stratum. Okay? But when you do cluster sampling, with the cluster sampling, you don't select the individual, you select the cluster itself, the group itself. Did you hear that one? Hello?
Hey, I'm here.
Yeah. So that's what happens with cluster sampling. You select the entire cluster, but under stratified, within the group, you select again. So you divide into groups, those are strata, then you select within the group. For example, you divide the country into provinces, that is stratified. Then we start selecting randomly from each province. Then for cluster, is when we divide the nation into provinces, right? Then we start selecting the provinces randomly, like the entire cluster to form the sample. I think you are getting that. Then on the fourth stage, you collect the data from the sample. Yeah. That sample which you have chosen. So you're going to say, maybe out of the 10 provinces, I'll choose 4 provinces. Then you choose them randomly, the 4 provinces. And then those provinces, they are forming the sample. Just heard about that, Vasa. You can quickly move on to systematic sampling. So under this, so these methods, by the way, they'll make more sense, especially when you start researching. Very much. It's very important to learn these methods of selecting sample when you're researching, because you cannot just be selecting the sample anyhow. For example, you want to study the behavior of let me just give you an example. You want to study the earning capacity of people, how much they get paid, who have good degrees. Obviously, you have to balance up and be careful in the way how you select your sample. Otherwise, you give us a wrong conclusion. You have to divide, get the people from Lusaka, get the people from other provinces, get the people from villages, like try to balance up and get people from different fields, of course, and sectors of the economy. So, but if you're just getting people from maybe one sector, then you are going to have wrong conclusions. So that's what we're trying to show you now. These are different methods of what? Sampling. So the other one is systematic sampling. Okay, it's a sampling method in which researchers select members of the population at a regular interval determined in advance. So at a regular interval determined in advance. So for example, you can say we're going to be selecting, for example, you have how many people? Let's say you have 100 people, right? 100 people.
Mhm.
Then you're going to say we'll be selecting every 10th. You'll be counting people random. 1, 2, 3. When you reach on the one who gives you number 10, you select that 10. You get. Maybe you say the 7th one, whatever number you say, you'll be selected. You get that one until you finish all the people, like you finish forming your sample from 100. And if you're getting the 10, it means your sample size will have how many? Only 10 people, right? Because you have to count 10. 1, 2, 3, form 10. Then the number 10th one you get. Again, you count the remaining ones. 10, 10, 10. Like you group the people into groups of 10, then count the 10th one you get. Did you get that one?
Yes.
Yeah. Now, the different types of variables that you have are categorical and numerical. So with the categorical, usually we also call it qualitative. We call them the qualitative variables. So these, they can only be placed in 2 categories or into groups, such as yes or no. Really, it's more like when you're forming questions, the questions that just allow people to answer yes or no, you can only be, we call them the binary variables. Yes, the binary variables, where you say, okay, you ask people, are you married or not married? You can just be married or not married. You can only be male or female, right? There are those things where you just have 2 answers, yes or no. You're following, eh?
Yes, I am.
Yes. Then the other type of variable, we call them the numeric ones. They are quantitative variables. Usually they give us values. So with the numerical variables, they are divided into 2. The first one is called the discrete variables. The discrete variables, they come from counting, like you're given a specific number. How many people are here? There are 5 people. Okay. How many discs do you have? You count the number. Like there's a specific number and a terminating number. Then the continuous variables, usually random variables. What happens is that these, they can give us a range of variables, like a range. They are not discrete, they are continuous. For example, the temperature. Okay, we can say what's the temperature today is 36 point, you understanding, point maybe 37. What is your weight? You can say maybe your weight is 60 or 70 point something kgs, right? The voltage is maybe 5 point something, just like that, you know. But for the discrete, you can have an example of the number of children, you know, just like that. They terminate in short. Then examples that you have under categorical: marital status, political party, eye color, you know, those things really. Yeah. Are we okay?
Yes, please.
The measurements are divided into scales, by the way. They have scales. The first one is the nominal scale. The nominal scale classifies data into distinct categories in which no ranking is implied. So there is no ranking for the nominal scales. It classifies data. We are classifying the data into distinct classes, but we are not caring about what ranking. Okay. So we
What
can
does
have,
this mean?
sorry?
What does this mean when we say no ranking is implied?
Okay. What it means is that we're just getting to, how should I explain it? The scale will just group the people into some group, but you are not getting the highest or the lowest. I'm hoping to get the example very soon. You're not getting the highest or the lowest. You remember the scale puts people into, it puts variables into how do I say, from the lowest to the highest, right? Most of the scales, like maybe the Likert scales, but for the nominal scales, it is not, it just classifies. It just classifies. Yeah, you're classified into this group, and then you're okay, just like that. Okay. For example, personal computer ownership. Do you have a computer? Yes or no? No, yes, I have, right? It just classifies you into some category, okay? But some ranking of some like of some kind is not there. It's either you just have or you don't have. You're following, eh?
Yes, I am.
Okay. So that's about that. Then the ordinal scale classifies data into distinct categories in which ranking is implied. So in this one now, ranking is what is implied. You classify the data into distinct categories. So in short, nominal scale is putting variables into some classes, right? The nominal scale that we dealt with previously, but there is
Yes.
no ranking. But
No,
with
there
ordinal
isn't.
scale, there is ranking that is implied here. So we are actually ranking. So you can see the examples that we have here. Student classification can be either a fresher, right? Yeah, you are a fresher, you are a sophomore. By the way, a sophomore is a second year student, or you are a junior student, senior student, just like that. Eh? So you see, there is a ranking of some kind. It categorizes you, but there is, but I'm sure you've gotten what you're trying to say. You are categorized, but maybe your class is lower than that, you know? The implication is that we want to rank. There's some ranking of some kind. Maybe product dissatisfaction, you can say someone is satisfied, they are not sure whether they're satisfied, they are unsatisfied. Okay? You're satisfied, you are just in between, and you're not satisfied. That's a ranking, right? You can fall in one of the groups, and there is a rank. You're following, right? Hello? Yeah.
Yes, I am. Sorry, I forgot I had muted. The baby came.
Okay. Faculty rank. You can either be a professor, an associate professor, assistant professor, or just an instructor, just like that, okay? When your grades are being ranked in the university, you can either get an A plus, an A B plus a B, a C plus a C, a D, or some F, okay? So in short, you are grouped into some group, but the way how you have been grouped, like there is some ranking of some kind. I think you've gotten the message under ordinal
Yes, I have.
scale. Okay. The internal scale is an ordered scale in which the difference between measurements in a meaningful quantity, or in which actually the difference between measurements in a meaningful quantity, but the measurements do not have a true 0 point. With an internal scale, what an internal scale does is that you have an order, like it's an ordered scale of some kind. So what is there is that the way how it orders or it classifies these variables, there is no zero. How would I say? Like zero is neutral, by the way, isn't it? You're following, eh?
Yes, I am.
Yeah, zero is neutral. So there is nothing like really neutral. So you are just there, up and then worse off. You're better off or worse off, but not really in between. Yeah, I know the clear implication of these things will come under research. These are things that you do in research techniques, like in detail, seriously. when you are getting to start researching. So you get to examine these issues now in a serious terms. Okay, you're following, right?
Yes, I'm here. Hello?
Okay, now. Okay,
Ah.
yeah. So now a ratio scale is an ordered scale in which at least the difference between the measurements in a meaning there is a difference between the measurements in a meaning of quantity, and the measurements have a true 0 point. Yes, they have a true zero point. So in short, this one gives the way the ratio, by the way, it means a fraction. Okay, the word ratio means a fraction of some kind. So what it means is that it expresses the variable, how they say, like in a fraction form. Actually, when you're doing the when you're doing data cleaning, actually in research, you SPSS does these things for you. How would I say it? Okay, what I'm trying to say is that it's more practical when you look at these variables on your computer and you get, not just memorizing in the head. Like you have to do. Then when you do, there is a clear understanding there of what we're trying to do. So what happens is that the statistical package for social sciences, SPSS, it's on your computer, like you have all these variables and the deeper implication thereof and how the variables behave, especially when you are regressing the variables. Okay.
Yeah.
Okay. Hopefully, I'm not even more confusing. I'm just as
No,
clear
no,
as
I'm
I should.
understanding.
Okay.
Yeah, very clear.
Okay. Descriptive statistics now. So we organize data. This is what I was talking about already in frequency distribution in pie charts, histogram, frequency polygons, stem and leaf, scatter plots, tables. Yes, just those are different ways on how you do what you categorize data. So in bar charts, you can use the bar charts actually to represent some ranking in terms of some variables. Okay, so usually the bar chart is marked against the frequency, like the individual variable against the frequency. For example, I think you can see the banking preference here. The banking preference, someone banks for ATM 16%, automated or live telephone 2%, okay? In person at branches 41%. These are some ranks, right?
Yes.
So you find that when you plot these against the percentage, you find that you draw these bars, okay? These are bars. You'll find that, what's this? For automated or live telephone has got the smallest frequency in terms of percentages, very smallest percentage. So even the bar for telephone is shorter than any other, right? And for banking in person is 41%, is even the highest. Even the bar itself is what is higher than any other. Did you get that?
Yes, I did.
Yeah, those are the bar charts really. So the pie charts, anyway, it's still the same thing, but what you're trying to do is that the largest percentage shall get the largest part of your bar chart. Like your pie chart is smaller, it's just like a circle, like this one. So the largest part will get, for example, the largest part in here is for people who go that bank in person at a branch. So that would be the biggest part of the pie chart. Okay. Then followed by the next one, it is followed by the 24, that is internet, right? Internet size, the 24 one will be a little bit bigger. Yeah, you just divide them according to the sizes. Then you give a key. This one is called a legend. This is a key. So the key is defined, since you've painted your pie charts in different ways. These pens, and you give a key so that you guide someone who is reading to know that, okay, here where they've painted purple or blue, they mean this, okay? Where they have painted violet, they mean this. You're following, right? Where they have painted maroon, they mean that and that.
Mhm.
You got that, eh? That's how
Yes, I have.
you create a legend. So when you make a pie chart, you need to create a legend. You create a key, in other words, so that somebody who is looking at your pie chart understands what you're trying really to imply. You got that?
Yes.
Now, just some caution here. We only use the pie chart when the data grouping is not more than 8. Okay. Like the grouping is not more than 8. 1, 2, 3, 4, 5. These ones are just 5. Because if you have got more than 8 groupings or categories, your data shall be clustered, or your pie chart will be clustered, which means like it will have a lot of things. It will be very small things you're getting it, right? So it will be difficult to see. You're seeing this pie chart that I've got. It's even difficult
Yes.
to see and notice. So you use the pie chart when the categories are usually less than 8, at most
Okay.
8. Yeah.
Okay.
The histogram, the histogram, the histogram is almost the same. By the way, it's almost same as the bar chart. The only difference is that the histogram is joined. Those bars are joined with the histogram. So what you do, you have got these different age groups. These are classes actually. These are classes. You've got the people that got 10, between 10 and 20, 20 and 30, and the last ones are 50 up to what? Up to 60. Okay. So what happens is that you also have the frequency. Okay. So the frequency is 3 between that. That is it. The people that fall, the scores that fall between 10 and 20, they were just 3. There were 6 scores between 20 and 30, right? And the
Yes.
5 scores between 30 and the 40. Then you plot. Okay. When you're plotting, you plot the frequency against this class. So you have the class between the 10 and the 20. The class between the 10 and the 20. 10, but less than 20.
Okay.
So that the frequency is 3. So you mark it here. Okay, you have that. Then the other one between but 20, but less than what? 30.
Oh,
Okay, yeah. So you find that this goes, the frequency is 6, like that. The next one, the frequency is 5, the frequency is that, then that is that. So you find that you're marking this against the frequency itself. Okay?
okay.
Yes, that's what you're trying to do. This is called the histogram of the frequencies, but there is a relative histogram. The relative histogram is when you are using the relative frequencies instead of using the frequency. You're using the relative frequencies. By the way, the relative frequencies are found by dividing the frequency divided by the total frequency. Okay, frequency divided by the total frequency. Did you get that one? So for
Yes,
example,
I
you
do.
have 3 divided by the total frequency is 20. Is it 20? 3 divided by 20. Okay.
Yes.
And what do you get? Do you have even a calculator where you are?
Mhm. No, I
There is
don't.
no calculator.
So 3
Next
divided by
time,
20, I'm getting 6.6.
6.6.
The recurring decimal. So 6.66667.
Are you sure? Like 3 divided by 20. Like 3 divided by 20. Not 20 divided by 3.
Oh, it's 3 divided by 20. Now I need a calculator now. Because I have to leave my screen to use the one on my phone.
Okay. So it is actually
0.15.
yes, 0.15. That's how you get these. So you're dividing each individual score by what? By the total frequency.
Yeah.
That's how you get the relative frequencies. Then the relative frequencies are the ones that you put here where there is a frequency and mark against the classes. That's how you get
Okay.
the histogram. Okay.
Okay.
I know there will be a question, of course. There was a question in that assignment. So I'm not getting too much in detail. I know I'll still talk about the same
Right.
kind.
Okay.
So don't panic. Yeah, just take it easy. And then for the line, when you're visualizing as well, even this one, you're just plotting the cost of day against the volume per day. Yeah, you're plotting, then you have this line as well.
Mm.
Okay, you'll have the line. So basically, this is how you present data. Like they have tried to summarize the data using these just a few methods that I've talked about here. Okay. So these are the ones that you have learned in class as compared to your notes are concerned. This is what you have learned. However,
Mm.
comma, I know that in the example that we have, maybe you might have something different a bit, but I have to stick to what you have done. That's why I also consult from
Okay.
notes instead of me overloading you with what you do not need.